Okay, next up we're going to be taking a look at the graph of a transformed cotangent function. So here we have our graph right here with these backward S shapes. Now we don't know what the equation is, but there's something else we can figure out about this transformed function, and that is its phase shift. What is the phase shift of this graph, g of x? Now, in order to understand phase shift, we have to know what the parent graph looks like, right? So let's go ahead and graph that on top of our parent function. Of our transformed function. So for step 1, we're going to graph the parent function on top of the transformed function. Now, to know how to graph the transformed function, you need to know those original 9x values ranging from negative pi to pi, and you need to know your unit circle really well. Okay, so I'm not going to keep telling you. You have to know those values like the back of your hand. So here is our parent function here in blue, our cotangent function. Now again, we don't know what the equation is of our transformed function, but that's okay. So what exactly is phase shift? Well, we know it's negative c over b if we have the equation, but what if we don't? Well, one way to define it is how many units, horizontal units, it takes for the parent function to shift from one of its center points or one of its origin points to its new center or origin point. So let's go back and take a look at these graphs and see what we're talking about here. Can everybody see that one of the center points of this S-curve would be right here? Okay. Now I want you to think about where the corresponding center point would be in the transformed function. And while you're thinking about that, let's talk about step 2. So once we've graphed them on top of one another, step 2 is to locate an identifiable point, or we could call it a center point on the parent function. Now if it was a cosine or sine function, just pick the top or bottom of the wave. That'll work. Now if you're talking about the parent graph, though, I guess actually with the parent for, what is it, not cosine but sine, it is in the middle of the wave, so pick that for sine. But if it's cosine, pick the top of the wave because that's its initial point. I guess either one would work. Alright, so locate the identifiable point on the parent function. So if we go back to the parent function, here's that center of the S. It's at negative pi over 2 comma 0. So that's going to be our first identifiable point. Step 3 is to locate the twin point on the transform graph. So where on the transform graph is that same similar point? Now, they're not the same shape, are they? No, they're not. But over here on a transform graph is also the point where the center of the S is, and that's at negative pi over 4 comma 3. So that's going to be what I call my twin point. And then step 4, we're going to use our definition of phase shift. We're going to take our new x value and subtract our original one, and that will give us the horizontal distance it takes for the shape of this graph to repeat, even though it's maybe been horizontally flipped or horizontally shrunk or stretched, who knows. But that will give us the phase shift. So let's take this x value, negative pi over 4, and subtract this one, negative pi over 2. It's a double negative, so it becomes positive. So we get negative pi over 4 plus 2 pi over 4, which is positive pi over 4, which tells us that the phase shift is positive pi over 4 units to the right. And that's going to be our final answer for phase shift, positive pi over 4. All we were given was the graph of the transformed function. If you have any questions about this video, let me know.